Inshallah, in today's class, we are going to discuss about the quadratic form of matrices. See on the board. What is actually quadratic form? A homogeneous expression of second degree. Any two variables is called quadratic form. For example, you see here, its degree is 2. X degree is 1, y degree is 1. So xy degree is 2. Here also degree 2. You see all these terms have degree 2, power, that is power 2. So this type of equations in any number of variables x, y, z, w, whatever, this is called quadratic form. So see here, quadratic form we denote as q equals to x transpose into a into x transpose into a into x. Now let me see, if the question is given in the quadratic form, how can we change into the matrix form? We do let me do one example on that. Now let me change into the matrix form. This given is the quadratic form. How they, let me see, I'm doing like this. There are many methods. I'm explaining like this. Watch carefully. Suppose we take in rough, we take, see what are the variables x and y and z. We are having three variables, so write like this: x, y, z. Here also you write x, y, z. Now watch carefully. Here what will be x into x? X square. So here you must get the x square. So x square coefficient you write here. X square coefficient is 1, so write 1 here. Here what will get? Y into y square. So here you have to write y square coefficient. Y square coefficient is 2, so you write 2 here. And z square coefficient, z into z square, so z square coefficient is 3. Z square coefficient is 3. Now next step is, watch carefully. So I wrote here 3. See here, next one is, here you watch carefully. Here you will get xy here. Here also you will get xy. So here and here you have to write xy coefficient. You see here, x into y, xy, x. But here when you write xy coefficient, you reduce it to half. Half of the xy coefficient, half of the xy coefficient. So xy coefficient is 4. But you have to write its half. Half means 4 half. The half of the 4 is 2. So write 2 here, 2 here. Again watch here, see here, what is here? Here you will get x into z. Here also you will get x into z. This term and this term will be same. It will be a symmetric matrix. Xz, xz. So here you have to write the half of the coefficient of xz. Xz is 6. So write half of it 3 and 3 here. The lastly you left here. You see here, here it will be yz. Here also yz, yz, yz. See, so let me write the yz coefficient by half of it. 5. Now we have to write 5 by 2. Here also you have to write 5 by 2. So this is the method. Let me denote this as a. Let a equals to. See, we change this quadratic form to matrix form. 1, 2, 3, 2, 2, 5 by 2, 3, 5 by 2, 3. Now watch carefully. Always the matrix changes into symmetric form. These two numbers will always be equal. These two numbers will always be equal. These two numbers. That is, it always reduces to symmetric matrix. Symmetric matrix. Let me see one more example here. Here the variables are x1, x2, x3. So let me take here x1, x2, x3. Like here also same x1, x2, x3. Now see here, here should be the coefficient of x1 square. X1 square coefficient is 1, so write 1 here. Here x2 into x2, x2 into x2, x2 square. So x2 square coefficient is 2 here, right? And x3 coefficient is minus 7. X3 coefficient is minus 7. Now watch carefully. Now here x1, x2. Here also x1, x2. Here x1, x2, here x1, x2. So coefficient should be reduced by 2, half. X1, x2, minus 4, no, reduce it to half. Minus 4 by 2 will be minus 2. We have to write half of this coefficient, minus 2. Here also minus 2. Now here what should be there? X1, x3, x1, x3. So x1, x3 is 8. We have to reduce to half. So it will be 4. It will be 4. Now lastly you see here, here you are having x2, x3, x2, x3, x3. We don't have the term x2, x3, so it should be 0. is 0. We don't have x2 x3 term, so it will be 0. Therefore let me write, let a equals to 1 minus 2 4 minus 2 2 0 4 0 minus. So the matrix will reduce into symmetric form. Now let me see the reverse process. If matrix A is given, how can we change into the quadratic form? See here, we have to change now into quadratic form. See this, this is x 3 by 3. That means we have to, three variables. Let I am writing like this. X equals, let me take x, y, z. So we are writing the quadratic form in terms of x, y, z. Okay. Actually, the quadratic form will be, we can write like this: x transpose into a into x. X transpose into a into x. But no need to write all that down. I am practicing you directly. You do one thing with this. You see here, let me have like this: x y z, x y z. Okay, so here you are having 1 2 3 2 1 3 3 3 2. Now see here, these are the squares terms. That is, this is x squared, this is y squared, this is z squared. So let me write this. First you see here, 1 into x square, 1 into y square, and 2 into z square, 2z square. I'm practicing this directly. Okay, finish. Then this 2 we have to double this one. This is 2, no, we have to write 4. This is 2, no, we have to write 4. Xy coefficient, this is, this 2 are xy coefficients, so you doubled it. This 2, no, we have to write 4 xy. So finished. Again you see here, this will be the coefficients of xz. We have to double this. 3, no, we have to write 6 plus 6 xz. Now lastly this is left. You see, this is yz, this is also yz, so this also we have to double. So we write like this: plus 6 3 double is 6 6yz 6yz. So we can write like this directly. Okay, let me see one more example. Suppose we are having some quadratic matrix A equals to 1 minus 3 2 minus 3 2 1. Here 2 1 minus 3. Now what will we be writing? You see, you practice this one. This will be xyz squares. So we can write like this: q equals to 1x square means x square plus 2y square minus 3z square, plus this term will be xy, this term will be xyz, no? So here xyz xyz. Okay, so here this is the coefficient of xy, but we have to double this one. So this will be minus 6 xy, this will be xz. So we have to double this. 2 means 4 4xz. Lastly this one is yz, so double this one. This will be 2yz. So this is the method to change into quadratic form with the matrix is given. So we have seen how to change into quadratic form and how to change into the matrix form. Let me continue this. Now see here, let me have some terminologies here. What is the meaning of index? You see here, the number of positive terms, the number of positive terms in a canonical form, in a canonical form of a quadratic form is called index. I will explain you with an example. Suppose you are having, how the canonical form will get, we get the numbers here, the remaining will be 0. Suppose 1 0 0 0 2 3, sorry, 0 0 0 1. Now see here, this is called canonical form. We get the elements numbers here and the remaining you make 0. Okay, this is the canonical form. Suppose we write, I will explain you these methods and everything later, inshallah. Just you see here, we apply this with this y1. Suppose like this: y1 square plus 2y2 square plus y3 square. Apply this y1 y2 y3. 1 into y1 square plus 2y2 square plus y3 square. This all are positive. Therefore, number of positive terms is called index. Index is denoted by n equals to 3. Suppose we are having like this. Suppose example, one more example. Suppose we are having like this. 2 0 0 0 minus 3 1, sorry 0 0 0 5. So how you write this? 2y1 square minus 3y2 square plus 5y3 square. So how many positive terms are there? These two are positive, this is negative. So number of positive terms is called index. Number of positive terms is called index. So index here is 2. This one positive, this one positive. One more example, suppose you are having like this: minus 1 0 0 0 minus 2 0 0 0 minus 3. So all are minus, so the index will be 0. So index means the number of positive terms, number of positive terms. Now what is the signature? Signature means difference between number of positive terms and negative terms. Difference between number of positive terms and negative. Its formula is 2s minus r. Let me see afterwards. So just you see an example. Suppose 1 2 sorry. Suppose we are having one example: 1 0 0 0 minus 1 0 0 0 3. So what is the quadratic form here? Canonical form is y1 square minus y2 square plus 3y3 square. y1 square minus y2 square plus 3y3 square. Apply with y1 here, y2 here, y3 here. Now and see here how many number of positive terms are here. 1 2 3. We are having two positive terms, so n equals to 2. And number of negative terms we are having 1. Negative terms we are having 1. So signature is the difference between positive and negative terms. So here the signature will be 2 minus 1 equals to 1. So signature means difference between number of positive terms and negative terms. Difference between number of positive terms and negative terms is signature. Now let we discuss about the nature of the quadratic form. Nature of the quadratic form. We reduce into canonical form and we can say the nature, or else we can see the eigenvalues and we can say the nature. Okay, we'll see afterwards the examples. First you remember this. Generally what is the meaning of n here? N means, you see here, n means number of variables here, x y z. Generally let me take example of 3 by 3 matrix, 3 variables x y z. Okay, let me understand. Now consider let n equals to 3. Now watch carefully. If rank and number of variables are same, rank also and number of variables are same, r means rank and s means number of positive terms, s equals to n means number of positive terms are equals to n, then we say it as positive definite. I'll explain you. If all the eigenvalues are positive, suppose you see here we get lambda's values as 1 2 3, all the values are positive, then we say positive definite. We say that the nature is positive definite, all the eigenvalues are positive. Suppose if all the eigenvalues are negative, suppose we are getting lambda equals to all the eigenvalues are negative, minus 2 minus 1 minus 3, all the eigenvalues are minus, we say this as negatives definite. Negative definite, the nature is negative definite. You see here s equals to 0 means number of positive terms 0, s equals to 0 means index is 0, that is no positive terms are there, that is all the terms are negative, therefore this is called negative definite. Its condition is r equals to n and s equals to 0. Rank and number of variables are same, rank and number of variables are same. Suppose we are having number of variables 3, number of variables 3, but lambda values we are getting one of the values 0, suppose 2 comma 5 comma 0. So this we got 0 lambda means the rank is only 2. Here the rank is 2, whereas number of variables is 3. So we can write like this: r is less than n. If we get one of the value, suppose minimum one value is 0, then the rank will be less than the number of variables. The rank will be less than number of variables, but the remaining two are positive. So this is called semi positive definite. We call this as positive semi definite. You see here, if rank is less than n, if rank is less than n and s equals to r, s equals to r, we say positive semi definite. The eigenvalues are positive but one or two values are 0, then we say positive semi definite. If rank is less than n and s equals to 0 means all the terms are minus, and one of the value is 0, like this. Suppose we get -2 -3 0. So this is 0, that means rank is 2 here. Rank is 2. Variables is 3, rank is 2. But all these two are negative. So we call this as negative semi-definite. Negative semi-definite. And indefinite in all other cases. Indefinite in all other cases. I'll give one example. Let me see here. Let me see some examples. Suppose you get, suppose the lambda values are, suppose you are getting 1 2 4. Now see here, the variables we are taking n equals to 3. Variables we are taking 3. Rank is also 3 here. Rank is also 3 here. Now s is number of positive terms. Number of positive terms is also 3. All the 3 are positive. So this is first case. This is first case. We say this is as positive definite. Positive definite. Positive definite. Now I will give one more example. Suppose you get lambda equals to -2 -1 -3. Now tell n equals to number of variables. We are already taking 3 variables only. Okay. So rank is also 3 because we don't get any value 0. No. If we get value 0, then rank will reduce. We are not getting any 0, so rank is also 3. But s is 0 here. S means number of positive terms. Number of positive terms. We don't have any positive terms here. So this is the second case. This is the second case. Since all are negative, we say negative definite. Negative. Nature is negative definite. Negative definite. Now second, third example. See here. Suppose we are getting lambda equals to 1 comma 2 comma 0. Now variables are always, we are taking 3 variables. But the rank here is 2 because this is 0. Now we cannot count this one. Rank is 2. If we get 0, don't count this. So we are having rank 2. So here the nature is like this. Rank is less than n. But positive terms are, both are positive. So s equals to r. Both are positive. This is also positive. That is s equals to 2, r equals to 2. S is also equals to 2 positive terms. So this is called positive semi-definite. This is called positive semi-definite. Suppose you get like this, lambda equals to -1 -2 0. Then we call this as, so n equals to 3, r equals to 2, s equals to 0. So this is negative semi-definite. Negative semi-definite. If you get other than this, suppose you are getting lambda equals to 1 -3, 2. 2 are positive and 1 is negative. So this is not any of the above 4 cases. So we call this as indefinite. If you get any of this 4, we are having the definite, positive definite, positive negative definite. But if we don't have this any of these 4 cases, we say this as indefinite form. Indefinite form. We say this as indefinite form. Okay. So we can have the nature by seeing the values of the lambda. By seeing the values of the lambda, we can see the nature of the quadratic form. See here, identify the nature of the quadratic form. First, let me change this into the matrix A. We've already seen how to change. Now variables are x1, x2, x3, x1, x2, x3. Okay. Now see here, x1 square coefficient is 1, so you get 1 here. x2 coefficient is 4, you get 4 here. x3 coefficient is 1, so x3 square coefficient 1 here. Now see here, here is x1, x2, x1, x2. Here we have to write x1, x2 coefficient reduced by half. x1, x2 is -4. Reduce this to half. -4 half is -2. So -2, -2. Here x1, x3. x1, x3 is 2. Reduce it half. 2 by 2 will be 1. So this will be also 1. x2, x3, 4. No? Reduce to half. -2, -2. So we get this as A. Let's write this as A. A equals to 1 -2 1 -2 4 -2 1 -2 1. Now to find the nature, we have to find the eigenvalues. For that we write the characteristic equation. The characteristic equation is, we know this, A minus lambda I equals to 0. What will be A minus lambda I? 1 minus lambda -2 1 -2 4 minus lambda -2 1 minus 2, 1 minus lambda equals to 0. So we get this one. What is here? 1 minus lambda minus 2, 1 minus 2, 4 minus lambda minus 2, 1. I'm not showing in detail because it takes a lot of time. We already seen how to solve this one. When we solve this one, we'll get the values of lambda. Okay, you try this by yourself. You try this by yourself. After solving, you get three values of lambda. Lambda equals to 6 comma 0 comma 0. Now let me see what is here. Now, first we see n equals to, number of variables are 3, so n equals to 3. Rank equals to, you see here, these two are zeros, now we do not count this. So rank is only 1. Rank is only 1. So S means index, number of positive terms. So don't count this 0. Positive terms are 1. So what is the nature here? R is less than n and R equals to S. R equals to S. So we call this as positive semi-definite. We call this as nature is positive semi-definite. Semi-definite. Okay, let me see one more example. Solving is already you have done in many previous classes. How to solve the eigenvalues. You see it from that previous classes. Okay, let me do one more example. Now see here, let me first change into the matrix A. We already have done this. We are having x, y, z. Here also we have x, y, z. Okay, now see the coefficients. X square coefficient is 1 here, y square coefficient is -1, z square coefficient is 4. Here xy, here xy. So xy coefficient reduced to half. 4 by 2 will be 2 here, 2 here. And here xz 6, no, 3, reduced to half, 3, 3. Yz is 2, that is 1, 1. So we get a. Let a equals to 1, 2, 3, 2 minus 1, 1, 3, 1, 4. Now the next step is for eigenvalues we write the characteristic equation is mod of a minus lambda equals to 0. So we get this as 1 minus lambda 2, 3, 2 minus 1 minus lambda 1, 3, 1, 4 minus lambda equals to 0. If you solve this one, you solve by yourself. Okay, if you solve this one, you'll get the lambda values as 0, 2 plus root 19, 2 minus root 19. Okay, you see in the previous parts you see how to solve this. Okay, now you see here, watch here. Now what is the rank here? See here, S is number, sorry, first here I am writing n. Number of variables are 3, so 3. Rank is 2 here, watch carefully, because this is 0, we are having two numbers, so rank is 2. And next one is index, number of positive terms. This is 0, don't count this. This one, this one, you see here, this is positive, this is negative, because root 19 is greater than 2, minus number is greater, so this is negative, this is positive. So S equals to 1. So see these three conditions, we do not have any in such 4. Okay, so accordingly there is no rule here, so we write this as indefinite. The nature is indefinite. The nature is indefinite. If we get S equals to 2, then we have one method. If S equals to 0, we have one method, but S equals to 1, R equals to 2, we don't have any 4 cases, so we write the nature is indefinite. So in the next class, inshallah, we'll see how to change the quadratic form to canonical forms. There are 2-3 methods, inshallah, we'll discuss in the next class.